For Calculus 2, we are asked to determine the total area of the region enclosed by y is equal to x cubed minus x squared minus 3x plus 18 and y is equal to x squared minus 7x plus 6 between x is equal to -1, which is this point right here, and x is equal to 6, which is going to be this point right here. So these are the 2 points we're looking at. We need to find the total area between each of these lines. And to do this, we are going to use area. It's asking us to find the total area. This is the key word. And to find area, we know that we can use the integral. And when we take the integral, we're looking at small parts of this. So we are basically going to break up this graph into small parts. We can either do this two ways. We can either do this from left to right, or we can do this from top to bottom like this. For this problem, the best way to do this is from top to bottom. From top to bottom is the best way because we want to keep this consistent. If we did from right to left or left to right, we would have it like this, where our left side would be either this graph and the right side would also be this graph. But if we do from top to bottom, we can see that we are going to have a different line every single time. We are going to have either this one or this one as the top and bottom. Also, if we were not given a graph, it is best to solve this using a graph. That way we can really look at things. So we should draw this out if we weren't given it. Now we know we have to find these two areas, and we are going to use rectangles basically to do this. And the area of a rectangle is going to be the height times the width. So we're going to find a bunch of these little rectangles that are in here. We are going to have a bunch of them that are in here, and we're basically calculating the area for every single rectangle. We are going to use the integral for this, and it's going to be the integral of the area or the integral of height times the width. So now we need to substitute in for h and w because we can't take the integral of h and w. So we can see what h represents. Well, h is going to represent the difference between this equation and this equation, because one of them is the top and one of them is the bottom. And the height is going to be y, we'll do subscript t for top, y top, minus y subscript b, or y bottom. The width of this is going to be the total run of this, the total size. But for this part, our red part is on top. And then if we look at this second part over here, our blue part is on top. So we're going to actually have to break this up and solve this 2 different times. We're going to have to solve for this left side that's in green because the red part's on top. And then we're going to have to solve for the right side where the blue part is on top. But for both terms, it's going to be y top minus y bottom. That's why we write it like this, so we can just substitute whatever's in top and whatever's in bottom. And then for the width, it's just going to be the change in x. Since we are moving along the x-axis, this can also be written as d of x. After graphing both of these, I was able to figure out that this one right here is going to be our red line, so I marked it in red, and this one is going to be our blue line, so I marked it in blue, respectively. We can use this to solve for our graph. We're going to finish writing out our kind of master formula, where we have our integral, and we have x is equal to some point, and x is equal to another point, again, because we have to solve these two separately. And then we have our height, which is going to be y top minus our y bottom, and this is being multiplied by our width, which is going to just be d of x. Now we can officially start solving this. We're going to look at the left side first. On the left side, our x, it starts at a -1 here, and then the red line stops being on top at a +2, so it's going to go to +2 here. Our y top for this equation is just going to be this red part right here, and so I have copied and written both of these down like this. We have our red part right here, the larger equation, which on top, and then our smaller part being subtracted from it on bottom, because it's y top minus y bottom, and then we have a dx right here. Next, we are going to look at this second part right here, and in here we are adding, because we are adding areas, and this is going from our +2 until our 6. And then in here, our top is going to be switched with our bottom. That means our top is going to be this value and our bottom is going to be this value. We can write out dx here, and then this is our equation that we need to solve for. The first thing that we should do is in both of them distribute the negative sign. So nothing is going to change, we are just distributing, and then we are going to simplify. We have our x cubed minus 6x squared minus 3x plus 18, and then we are subtracting an x squared plus 7x minus 6 with a d of x still. We are adding this to our integral from 2 to 6. We can't combine these integrals yet because they have different boundaries. We are going to factor in our negative here just like we did for the other part. We're going to have a negative x cubed, a positive 6x squared, and a positive 3x minus 18 with a dx here. Now we can start combining things respectively. For this part, we only have one x cubed, so that's going to stay the same. We have 2x squareds right here, so when we rewrite this, we are going to combine them. We're going to have a negative 7x squared. Next, we look at our x's. We have this x and this x right here. Combining them is going to give us a 4x. Now we look at our constants, this 18 and this 6. Combining these two, we are going to get a 12 dx. Now we have to add our next part, which is going from 2 to 6. We have a negative x cubed, only one of them, so we're going to have it out here like this. And then after this, we are going to start looking at our x squareds. We have 1x squared here and 1x squared here, so we are going to add these together, and this is going to give us a positive 7x squared. After adding our x squareds, we can look at our x's, and then we are just going to get a negative 4x here. Lastly, we are going to add our constants. We have this plus 6 and a negative 18, so adding them together, we are going to get a negative 12 dx. Now we can take the integral of both of these and then do math to add them together. Taking the integral here, we are going to have x to the 4th over 4 minus 7x cubed over 3 plus a 4x squared over 2, but this is just going to give us a 2x squared. We can simplify this. And then we are going to have a 12x, and this is going from negative 1 to 2. Now we can add this next part. We're going to have a negative x4 over 4 plus a 7x cubed over 3 minus 2x squared minus a 12x. Still, we cannot combine these yet because we have different boundaries. Next, from here, we are just going to put everything in. The first part, we are going to have a 2 to the 4th power, which is going to give us 16. 16 divided by 4 is going to give us 4. And then we have a negative 7 times 8 divided by 3. So we'll just have a negative 56 over 3 plus a 2 times 2 squared. That's going to give us 8 plus 24. Now we have a negative, and then we plug in our minus 1. So we're going to have a 1 over 4 plus a 7 over 3 plus a 2 minus a 12. Close this off and solve for the next part. Plugging in our values here, first we have a 6. So with our 6, we have 6 to the 4th power, and this should give us a 1,296 divided by 4. Then we are going to add 7 times 6 to the cubed. 6 to the cubed is 216. We are multiplying this by 7. That will give us 1,512 divided by 3 minus a 2 times 6 squared. 6 squared is just 36, and we are multiplying 2, which will give us a 72. And then from here, we are subtracting a 12 times 6. 12 times 6 is also 72. Now we have to subtract the last part with the 2 in it. So from here, we will have a negative and then our parentheses, and inside of here, we will have a 2 to the 4th power, which is going to give us 16. 16 divided by 4 is just 4, so we have a negative 4 inside of here. And then we're going to have a 2 cubed times 7, which is 56, so we'll have 56 over 3, and then we need a 2, basically 2 cubed, because we have 2 times 2 to the 4th, so this is going to be a negative 8, and then we have 2 times negative 12, which will give us a negative 24. And so this is our answer right here. This is our final answer right here. This is our area. Now all we need, or all we should do, is plug this into a calculator very carefully. There's a lot of parentheses and subtraction and different addition signs, so it's super important to plug this into a calculator properly. After we plug this into a calculator carefully, we will get that our answer is approximately 78.03.08 3, and it just repeats 3 forever. And this is our area. To find the area, we had to break this up into two parts because we have a different top and bottom line. We had a integral to find the area. Then we had a high, which was y top minus y bottom. Then we had the height, which was y top minus y bottom, times the width, which was just the width of our specific shape. And then we added both of them together. After doing all of our addition, we got our answer. And this is how you determine the total area of the region enclosed by two shapes or two y or x functions.